move to another board. And here we are. What we will be doing in this board. Very, very interesting board, right? So let's bring our Mr. Prashant Patil back into action. When we started this course, we were talking about a building, guys, right? And we were thinking about that building, that what is going to be there in terms of networking, right? Now we have enough understanding of switching. So from switching perspective, we can think about the design, whatever, or the devices in this building are, right, from the networking perspective. So we have Mr. Prashant Patil. Mr. Prashant Patil has Sports India, and it's a great organization. It is growing like anything, right? Suppose he has a first building in Gurugram, northern part of India, right? And there he has four-story building. But you can say, Mr. Vishnu, it is a five-story. That is fine. Here, whatever we have is a parking. So leave it. We have around 30-40 people here on the first floor, right? And then around 30-40 people here in the second floor. Then third floor, we have around the same number of people, around 40, right? And this floor is empty. Maybe when Prashant ji hire new people, they will be putting them on the fourth floor. Maybe, right? When we see a little bit closely here, there are going to be different departments. Maybe we have sales department here in the third floor. We have marketing and we have engineering department. Similarly, sales, marketing, engineering here, sales, marketing, engineering here, right? I am thinking from the perspective of a network engineer. When we see building, we see routers and switches in that, right? How basically this building is connected, how people are using network of this building, right? And that is what this individual who is an employee of Mr. Prashant, the name is Rahul, he understands switching well. So when he sees sales, marketing, engineering folks, something is cooking in his mind. He's seeing network like this. He's really assured that we need to create at least three different VLANs. I do not want that sales guys get confused with the marketing traffic or engineering traffic. I will be putting them in separate virtual LANs, right? And this is what he's thinking right now. And now he is also thinking that how many switches I am going to need. Maybe can I buy a really, really big switch, a modular switch, which is maybe having more than 200 interfaces? Why can't I have that, right? I will put that somewhere in the room and I can connect all these guys here. I will be creating the VLANs on this switch and then that is it. Maybe inter-VLAN routing I also should be enabled on this switch, right? But Mr. Rahul is an intelligent man. He is thinking, what is going to happen in a scenario when this switch goes down? If this switch goes down, then there is a problem, right? Nobody is going to be able to communicate with anybody, right? Even folks in the sales department are not going to communicate with the sales in the same floor because everyone is connected to this huge switch, right? I'm talking about this kind of a design which is in mind of Mr. Rahul, right? And Mr. Rahul, whatever he was thinking, he said no. Although the design looks similar, should look similar to this, but I cannot connect everybody on a single switch and make it a single point of failure. If this switch fails, if something happens to this switch, nobody is going to talk with nobody, you can say, right? Interesting. So he's thinking and thinking aloud, and Prashant ji and Rahul both are discussing about because their network is in initial state, right? They need to build a solid base. Maybe, you never know, Mr. Prashant needs to hire or get another building on rent. Maybe he's going to have 500 employees, maybe 1,000 employees in the Gurugram itself, right? So what he's going to do, he will be renting another buildings, right, which are nearby, so that these employees can come and work there. And if that is the case, we are building a network which is really close by. Maybe a campus, maybe a campus for Mr. Prashant's office. As simple as that. So this is just the beginning. Mr. Rahul is thinking to begin with that can we make on a single switch? And it is straight away discarded by his mind only that no, I do not want a single point of failure. This is a single device, right? So what he's thinking? He's thinking, can we do something that I buy a 48-bit switch, sorry, 48 not bit, 48 port switch, and can I put on every floor? This makes sense, right? And that is what he's doing. For that, let's move to the next board. And that is what he's doing right here. We will discuss about these switches later, guys. But first thing first, what Mr. Prashant ji's employee, Mr. Rahul, is thinking. Rahul is a great network engineer, right? So he's putting some of the switches. Maybe this is switch number 1, this is switch number 2, this is switch number 3, right? And this green line is for VLAN, maybe say sales VLAN, right? This is marketing VLAN. This is engineering VLAN. I cannot show you cable for all the 40 people, but you try to understand when these people come with the laptop. They might be having the desktop also, right? Some servers are here, right? And this can be of the sales laptop. This can be of the marketing desktop, and this server belongs to maybe engineering. Say, interesting. You need to connect them on the different port of the switch. So if there are 40 such devices here, we can connect them, right? And Mr. Prashant ji is defined here that this is for VLAN number sales. Sales, he is giving 10, then 20, then 30, whatever, right? So you can understand that these 40 devices can be connected to a 48 port switch. And the interesting thing is this is only a layer 2 switch. So Mr. Rahul is thinking about the budget also because Prashant ji is always there, right? Switch 2 is again the layer 2 switch. He is connecting the second floor of the building and then the first floor of the building, and he is good till this point, right? Now he is connecting these two, and you must be thinking, Mr. Vishnu, why do you need another pair of switch here, right? If these VLANs want to communicate among themselves, then you can make these, you can use some of the links and make them ether channel, or maybe a single link also, right? So that these switches can talk. And definitely there is no doubt about it that if somebody in VLAN 10 at this building or if this floor wants to communicate to VLAN 10 of floor number 1, how the communication is going to be? From here, it will be coming on the VLAN 10. Over the trunk, it will come to switch 3. And then basically over the VLAN 10, it will be moving like this. As simple as that. But here is the problem. The problem is, how come somebody who is part of the VLAN 10 will be able to communicate to somebody who is part of VLAN number 20 here, right? On the different floor, or maybe on the same floor also. Mr. Rahul ji bought these switches which are layer 2 switches. They cannot do layer 3. You cannot create SVIs on it. But yes, absolutely, if they have bought the layer 3 switches, then this problem could have been solved, right? But Mr. Rahul is not just thinking solving the problem. He is thinking what is going to happen if there are few more buildings in Mr. Prashant's organization. If that is the case, there might be 4 more buildings. Everybody is having 200 people in that. In that case, what is going to happen, right? And that is why he has bought two more switches, right? So he's calling this first layer of switches as access switches. Why access switches? Because you can understand whatever the devices are on these floors, they are accessing the network through these switches. These switches are the interface of the network, right, for them. If a laptop on the VLAN number 10 wants to communicate to anybody in VLAN 10 of the other floors or the same floor, this through this switch they are accessing other devices. It is as simple as that. So Mr. Rahul is saying that these are my access switches. As simple as that, right? Now, what exactly he is doing? He has bought two more switches. And believe me, these two switches are layer 3 switches. He can make SPIs on it, right? So what exactly he is doing right here is that he is making switched virtual interfaces. This is the SVI for VLAN 10. This is the SVI for VLAN 20. This is the SVI for VLAN number 30. And of course, these are going to be the default gateway. As simple as that. These links, whatever you are seeing right here, these are all layer 2 trunk. And if you are thinking, then all of these links are up and running at all time, then you are absolutely wrong. And the reason is we have spent at least 2.5 hours in learning an important concept, which is spanning tree protocol, right? Suppose this is my root bridge, then what is going to happen? This link can be up, but this link cannot be up. This link can be up, but this link cannot be up. Similarly, this link can be up, but the other link cannot be up. As simple as that, right? And then, of course, if we have a link between them, then basically this link can be up. And you can calculate it very easily, which links are going to be up and running, right? So although I'm not saying that we are making an efficient network, we are just making a network. We are just providing the connectivity. That is it. But now in this scenario, if VLAN 20 or VLAN 10 on this floor wants to communicate to VLAN 20 of this floor, how they are going to communicate with each other? If I draw the traffic path, the VLAN traffic will come from here to here. It is going to the access switch, no doubt about it. And of course, only one link should be up and running. I'm presuming this link is up. So it is going here. And of course, VLAN 10 is communicating to VLAN 20. The communication is in two different VLANs. If that is the case, routing must be performed. And that is why we have SVI here. If VLAN 10 wants to communicate to VLAN 20, the packet should reach to the default gateway first, which is the switched virtual interface. And that is why the traffic will be coming here. Here, the decapsulation is going to happen for the packet and the IP packet will be taken out. And in the IP packet, what you are going to find? You are going to find the address of VLAN 20. And who is the VLAN 20 SVI? Right? This is the one. So packet will be reaching to here. And here the again encapsulation will be happening, right? Because the IP packet is here, right? And it needs to go to the VLAN number 20. But at which floor? Floor number first. Then it will be going from here to here, as simple as that. And then it is going over this VLAN 20 and reaching here. This is the simple traffic flow. As simple as that, right? So by the way, guys, any moment, because right now we are already at 30 minutes. If any moment you find a problem, just let me know. Okay. Although it is very simple things. So when you see this building, and when you see a topology like this, don't worry, right? Because this is what network engineer sees. And that is what I have drawn here in the next board, right? So when you see an office building, believe me, inside this network is going to be like this, right? So if I draw some of the things here, if I want to draw how a green host or the green laptop should be able to communicate to the yellow laptop, whatever I have shown, first floor, maybe this is the first floor switch, this is the third floor switch, right? The traffic will be going from here to access switch first. And because this is the root bridge, so maybe you are sending like this, it is coming like this, and then reaching here. And of course, if routing needs to happen, routing will be happening through SPIs, right? We have this layer 3 device. As simple as that. And suppose now what is going to happen? Let's consider a failure scenario also. Suppose this link is down, this one, and it is going to be interesting traffic path. Green host wants to communicate to yellow. How it is going to do? Traffic from this switch or the host will be coming here. We are communicating between different VLANs, guys. This might be 192.168.10.10. This might be 192.168.20.20, right? And of course, if 10.10 wants to communicate to 20.20, the traffic should move to the default gateway first, right? And default gateway is what? SPI. Where we have configured SPI on switch number 1, right? So what is going to happen? The traffic will come from 10.10 to the switch, and suppose this link is down, there is only one link. Spanning tree will be making the block port unblock if this link goes down, although it is going to take maybe 30 to 50 seconds if we are running spanning tree protocol, the old one. If we run RSTP, then it is a matter of few seconds. But right now, we are just building the network. We do not care. Maybe when Mr. Prashant Patil ji come into the business of maybe some banking or financial services, then there every millisecond even have some value, right? Then we need to make sure that our network should not go down even for 1 second or half a second, right? But now we are just starting the building. We are just starting how to build this network, right? We are just working on that. So that the traffic comes from this host to this switch. Spanning tree will unblock this port and it will reach here. But unfortunately, it is not going to find any SVIs here, right? Why? Because this is my layer 2 trunk. Everything is layer 2 trunk, and I haven't defined an SVI here. And you must be wondering that, Mr. Vishnu, why you didn't define SVI? Because SVI is one address, right? Which is 192.168.10.1/24, which is going to be the default gateway for this host. We can configure only one default gateway for this host, which is 10.1, which can be either on this switch or on this switch. It is as simple as that. If you go and create an SVI here, with the same IP address 192.168.10.1, but the problem would have been solved, right? But you cannot configure 10.1 here because you have already configured here. And it is going to give you error that there is a duplicate address detection. We have read about our probe messages. We have read about gratuitous ARP. And with the help of those, the system will come to know that there is a duplicate address detection. And that is why you cannot create the SVIs on this switch with the same IP address. There is no doubt about it, right? Then what is going to happen? I'm not saying that there is a problem. Definitely, if this path is gone, then 10.1, your traffic can go from here to here to reach the green SPI. Definitely, it needs to just reach the SPI. It is as simple as that. It will be reaching here on this SPI. Routing will be happening, right? There will be routing. The packet will go to the yellow VLAN, and from there, it will come to know that it has to go on the third switch, and then from here to here. It is as simple as that. Believe me, it doesn't matter in which organization you are working. If you do not understand these traffic flows, troubleshooting is going to be absolutely difficult. And that is why people say troubleshooting is difficult. Guys, troubleshooting is not difficult, but to put your initial brain on the topology is actually difficult, right? Believe me, I have seen network engineers who do not have any idea about their network and then they say troubleshooting is difficult because troubleshooting an entire network is going to be really, really messy. But if you know the traffic flows and if you understand how your spanning tree is behaving, what exactly your traffic flows are, you can straight away say that out of this big problem, the problem lies in these few devices. Just go and troubleshoot them, and you will be finding the solution instead of troubleshooting your entire network. Because if you troubleshoot the entire network, it is going to take time, and that is why troubleshooting is difficult for many people. So the good approach is, believe me, from my experience, I am saying if you just draw your network, specifically switching, if we are talking about switching here, just see the traffic pattern, just see the traffic path, just see the failure scenarios, right? I'm not saying that there is no solution to this problem. Definitely, we will be learning about how we can make another gateway like this in the same system. The meaning, what is the meaning? The meaning is 10.1 can be here on this switch. Believe me, it can be there. And that is where we are talking about gateway redundancy. We need to make this gateway redundant. We need to make one more gateway so that if this goes down, right? So I'll take one more example. So I think this traffic path is clear to you, right? There is no doubt about it. I'll take another example where I will be putting the need for gateway redundancy also, right? So what is happening here? Suppose green host wants to communicate to yellow host, and right now the traffic path is going to be like this. Don't doubt about it. Routing is happening at the root bridge. Now suppose in an unprecedented event, this goes down. This goes down means this link is going down for sure. Spanning tree will immediately make this link up. Previously, it was blocked by a spanning tree. So what is going to happen? This host will try to reach its default gateway, which is 10.1, right? And now 10.1 is not there at all because the switch is down. It is going to send an R for 10.1 to begin with, and this switch doesn't have any idea about it. No one is going to reply with it. That means that we have a single point of failure. If the root bridge goes down, where we have configured these entire SVIs, then it's a problem. It means that somewhere we need to define this 10.1 somewhere else also. And the problem is if I define 10.1 here also on the SVI, it is going to create a problem because of duplicate address detection. But with this, you should understand that there is a need of 10.1 IP address anywhere else also, because if this goes down, it is a single point of failure. And there are, and we call this as gateway redundancy. We need redundancy for gateway. We need another gateway so that if this goes down, the other gateway can come up. But the problem is we cannot make 210.1. This is the same issue, right? Believe me, your first hop redundancy protocol solves this problem only. You can have 192.168.10.1 here, and you can have 192.168.10.1 here. How? We will be talking about it, right? But through this traffic flows, I believe you all understand that there is a need of another gateway, the same gateway. Having said that, Prashant Patilji have a question, and why not? It's his network, right? Mr. Prashantji, please ask your question.
Vishnu, let's say I want to configure the management IPs for the L2 switches.
Mhm.
So in that case, do we need to create a L3 VLAN?
Actually, for management, basically for these L2 switches, it gives it one functionality, one basic functionality for us. For basically one VLAN, VLAN 1 specifically, you can create an IP address on it, right? But if you want to create other SVIs, it depends, then it should depend on the switch model, whether it's support or not. Okay. A
Okay.
pure layer 2,
So,
because anyhow, you need to reach to it, right? It should have an IP address. So basically, by
okay.
default, it gives you one interface so that you can configure the management IP address.
Okay. Let's assume I configured the IP. Like here we have three L2 switches.
Hmm.
I configured three different IPs.
Hmm.
So in order to reach these three switches, so we need to configure the default gateway, right? Like either static default route or IP default
From
gateway.
where you want to reach, first thing first. For example, you have
From
from outside. Okay.
from outside.
So
Yeah.
basically,
So on.
we have a router here, right? And you are sitting somewhere here, and you want to
Yes.
manage this network, right? Then what you need to do is you need to create, definitely, maybe on VLAN 1 you have placed an IP address which is 192.168.10.1. Okay, maybe,
Yes.
right, or 10.2. And then you can make this port as the access port in the VLAN 1 and configure another IP address here, 192.168.10.1. You can do that, right?
Yes.
And then you can define a default gateway in the switch also. The default gateway for this switch is 10.1 because you cannot define the route here. If you cannot define the route in the switch, the default gateway you can definitely define there. Okay.
Okay. So it will be IP default gateway, right?
Yeah, the command should be IP default gateway.
So
Okay.
if I want to use static default route, is it that is also possible,
I
right?
don't think that the IP route command is there in the switch. If
Okay.
you are talking about L2 switch, not L3. I'm presuming this is the L2 switch, pure L2. Okay.
So assuming that no IP routing is enabled on the L2
Yes,
switch, right?
yes, yes.
Okay.
But still, you can
Okay.
give the default gateway command.
Okay.
Okay.
Thank you.
Then basically the traffic can come here and go, no doubt about it. But it's a good question. So I think, if I may ask, uh, that do you guys understand the need of a redundant protocol, or basically gateway redundant protocol? If not, that is perfectly fine, but I presume that you should understand. Otherwise, somebody would have asked question. Now let's talk about, here we are talking about one building, but now what is happening, guys? Mr. Prashant's business is growing like anything. He has another building now, right? In this building, he has approximately 130 people, and the new building he has approximately 120 people. Interesting. Now, what is going to happen? Let's see. So we are right here, okay? And now you might be understanding the need of these distribution switches. First thing first, they are doing the inter-VLAN routing for sure. There is no doubt about it, right? And now, what is happening, guys? Suppose we have three VLANs here, VLAN 10, VLAN 20, and VLAN 30. And here also we have those VLAN for sure, 10, 20, 30. But we have another few VLANs, maybe VLAN 40, 50, and 60 also. Suppose. Why not? We can have that, right? This building and this building can be different in terms of VLANs. It can happen. If that is the case, what is going to happen? What I've done is, if you see this white link, this is the trunk link. If you see this blue link, this is the layer 3 link. It means that I have converted this port of the switch as layer 3. this port of the switch as layer 3, and maybe I am running a routing protocol, and that is what I have discussed in the first board of this class, right? So what is going to happen, guys? Here we have 40, 50, 60 VLAN. It means that we have a network for this, network for this, and network for this. How come this guy will be able to know about these networks? Of course, definitely. We are advertising it over this OSPF or maybe whatever the protocol you are running, and we will be advertising this 40, 50, 60 network to this guy. Interesting, right? It is already having network for 10, 20, and 30. How come? Because these are directly connected here. No doubt about it. And we are actually having 40, 50, and 60. And if I'm writing 40, 50, 60, just presume that these are 192.168.40.0, 192.168.50.0, and 192.168.60.0. Maybe because these network can be anything, right? These are OSPF LAN route. These are my connected route. As simple as that. You must be thinking that Mr. Vishnu, we have created some SVIs here also for 10, 20, 30. Aren't we going to advertise those? Maybe if you can advertise, but still router is going to, or the switch is going to get the connected routes, right? So if you do not know about it, just see my routing course. Believe me, routing fundamentals, if you see for the 12 hours, and the switching fundamentals, if you do for 12 hours, it is more than enough to build that solid base for you, and then you can create your career building on top of it. But if this base is tilted, believe me, it is a problem, right? What about this trunk link? This is talking about the link between those two distribution switches, right? And I have allowed VLAN 10, 20, 30, 40, 50, 60 on it. Interesting. Now let's understand how VLAN 10 here can communicate to VLAN 10 here. And believe me, we have extended the VLANs, guys, between these two switches, which is not a very good practice. But sometimes some VLANs need those extension. And what is the reason? I can give you this to you. Please just start thinking about it. Why do we need VLAN stretching between two buildings, right? These two buildings might be maybe say in the same campus area, maybe 800-meter apart. These two buildings can be maybe 1 kilometers apart. Interesting, right? Then you must be thinking that, Mr. Vishnu, if that is the case, the Ethernet wire can go only 500 meter. Why? Then it's a problem, right? I'm not saying this is the Ethernet technology. You can use the fiber optics. Maybe these two buildings are 1 kilometers apart or 2 kilometers apart, right? But we can still run the fiber cable between them. Or we can take help of a service provider also to connect, and they can give me this trunk link, right? I am giving my link to the service provider. Service provider is taking that link and providing the other end of the switch, right? And whatever you need, the layer 2 or layer 3 trunk, you just let them know and they will do that nothing. Or maybe if it is 1 kilometer, you can build your own cable. But now we need to understand the traffic flow. We need to understand the traffic flow between VLAN 10 of the building 1, which is this one, and VLAN 10 of the building 2, which is this one. As simple as that. Let's draw it. Communication is happening inside the same VLAN, guys. So we are not going to default gateway. The traffic will be coming for the VLAN 10 over this green wire. And of course, it will be reaching to the distribution switch over this trunk, another distribution switch over access, and straight away it will be going like this. Now let's try to understand what is going to happen if VLAN 10 wants to communicate to VLAN 20. Maybe on the same floor or different floor, doesn't matter. Maybe VLAN 20 can be here. Also, the host can be here, and the VLAN 10 is right here. How the communication is going to happen? Just remember, if we are communicating between two different VLANs, it means that routing must be somewhere, right? It means that we need to pass it through a routing capable device. And here we do not have router. We have SPIs or a layer 3 switch. So VLAN 10 is going to send this traffic towards this SPI, which is the default gateway, and then it is going to send it towards the VLAN 20. See the traffic flow from VLAN 10, it will be coming over this green link. Now, because we need routing, right? And interestingly, this link is down because of a spanning tree. Guys, what is going to happen? Or maybe I am wrong. Maybe this link is not down because this is a root switch, right? So what is going to happen? Suppose we come from here, from the VLAN 10 over the green, right? Then from here, we will be going here. What is going to happen, guys? We will be meeting a SVI here, right here on the green interface. And then what is going to happen? We will be going towards the yellow interface because yellow is the VLAN 20, right? And this is a trunk link which can take the VLAN 10 traffic, which is connected to again back to the switch 2. So we need to send this traffic back towards this switch. Very, very interesting, right? Right? And maybe this is going like this way, coming to this switch, and then here, and then here, and then to VLAN 20. It is as simple. And it depends on basically what your ports are available in the spanning tree domain. As simple as that. Interesting, right? Or maybe you can connect these two switches together. If that is the case, if the traffic path is going to be even simpler, what will be happening? VLAN 10 here it will be going in, routing will be happening, right? And let me connect this. What is going to happen? It will go here, over the trunk link, here, and here. As simple as that. Now, suppose VLAN 10 wants to communicate to VLAN 40. Very, very interesting case, right? Again, we are communicating between two different VLANs, VLAN 10 to VLAN 40. Routing should be there, and route should be there importantly, right? So what is going to happen from the traffic? It is coming here, from here it is coming here, and now it is going to be routed, right? And this switch is running the OSPF route over this blue link. It will be going like this. From here, this switch must be knowing the VLAN 40. Maybe it's in, maybe the host is in the floor number 3. It will be going from here to here, from here to here, and that is it. Guys, these traffic flows are really, really important because if you understand them, then you are one step closer to designing the network. And you must be thinking, Mr. Vishnu, whatever you are designing is not that efficient. I totally agree with you. This is not at all efficient design, right? But what I'm saying, because right now I have only one switch on which is doing routing, right? If this fails, then basically it is going to be single point of failure. VLAN 10 is not going to talk to VLAN 20 at all, right? But believe me, what we are doing is we are making a network which is 10, 20, 30-year old. Believe me. But we are building that base because if we understand the problem in this network, we can try to fix it. First problem we just saw is the gateway redundancy problem, right? We will solve it and you will be amazed to see that the protocol which we are going to use it for HSRP, right? First hop redundancy protocol or GLBP or VRRP, which is solving exactly this problem. So if you understand the old network, if you understand the problem of the old network, then you can understand the new network, new networking technology. Maybe you can, why you have these two different switches? Why can't you make these two different switches looks like one? And this is what the VSS technology is. If you heard about it, we are not going into the VSS technology or stack-wise virtual. No, The reason is if I do that, then switching course itself is going to be 30 class long, right? But with this, I would like to put something in your mind that believe me, if you have this kind of switching knowledge, you can understand the entire campus network. Why exactly VSS come into picture? These links were blocked by STP. Why? Because STP is seeing the loop. And if we can make these two switches look like same to STP, then STP is going to be behaving like that. You can connect two interfaces to it, and these are going to be up. Because now for STP, these are two single switches. And this is what my VSS does. Virtual switching stack, I believe. No, virtual switching system, I believe, right? Or in the new switches, it is stack-wise technology, right? The whole sole idea is I am just putting something into your mind so that, see, we are creating an inefficient network so that you can understand the importance of efficiency. You can understand that these concepts are not coming like from the air. No, because we were facing, see, we have started switching from 1970s, right? We are into 2023. If you are here, you cannot just understand each and everything, right? If I explain you VSS directly, you'll be thinking, yes, the solution is good. It is making two routers look one. But you never ever be able to understand why exactly it is coming into picture. If you do not understand that to avoid some loops, we are introducing STP. Now the STP itself is a problem. It is blocking a lot of my links. And now I'm bringing VSS. As simple as that, right? So you are learning an entire journey, and this is the problem which people do. Right? Sorry, this is the methodology which people choose, that they try to understand everything, whatever is going on in 2023, and then they say they are not getting it. And the reason is because you do not know the history, because you do not know why these technologies have come into picture, right? The whole sole idea of today's class, the whole sole idea of showcasing you traffic path is that some of the traffic paths are inefficient. If you want to make them efficient, let's introduce VSS. Let's introduce HSRP into the picture, right? Let's solve the problems. And of course, I have bringing the internet here. Mr. Prashantji is saying why my organization need internet. They should work only. Then somebody, Rahul, says that Mr. Prashantji, if people, if you want people to work, let them free also for some time. And that is why we have internet, right? So that they can watch some of the videos on latest technology or anything they want, right? It's a liberal organization. And that is why I have connected to some of the links to these layer 3 switches and taken the services of maybe Geo or Airtel, and they are starting using the internet also. And you can draw the traffic path for the internet, right? And it is going to be very, very easy. So now if VLAN, somebody from VLAN 10 wants to communicate to the internet, they are coming over this switch. Of course, the routing is happening here. The default route is going to be here. They will go like this and then access the internet. As simple as that. Interesting, right? But now, still, Mr. Rahul is saying that the network can be increased because Prashant just reached to Mr. Rahul and he is saying that he is about to hire another 300 employees and he has rented two new buildings. And then Rahul is saying, okay, I'm ready for it, right? Right now, you can understand the need of this access layer. And now, basically, this layer of switch is actually distributing my traffic to another buildings, right? So we call this as an access layer. This is my distribution layer. Again, here in this building, this is my access layer. This is my distribution layer, right? But you must be thinking that Mr. Vishnu, Cisco suggests three different layers. Access, now you understand distribution, and it also says core. Believe me, Many organizations can work with the distribution and access, but some large organizations case we need the core layer. And let me show you that large organization, because Mr. Prashant Patilji business is growing like anything. Now they have 4 different buildings, and see this beautiful diagram. Really, really interesting, right? And there is no doubt about it that we can understand that this is my building and this is my building network. This is another building, maybe building number 2. This is the network for it, right? And now I am connecting them. Believe me, if you need to extend VLANs, then sometime it is going to be a bad design in current scenario, because now extension of VLAN, if you do that, then basically you need to connect this distribution switches over the trunk link, right? Try to understand. You are increasing the domain of address resolution protocol, which nobody likes. You are increasing the domain for errors, right? So what I'm doing here is just try to understand if I need to extend VLAN. Believe me, this extending of VLAN is not like that you need to do it for every VLAN. There are going to be many few VLANs which need extension, right? But in data center case, right, most of the VLANs need extension. Why? We will be understanding them, but we are not talking about VLAN extension here, because VLAN extension in modern environment leads to VXLAN. We will be talking about it in the third course, right? But just have a look at this, right? We have introduced another 2 switches. These are purely layer 3 switches. I'm not saying purely because this is a wrong statement. These are the layer 3 switches capable of doing high speed packet forwarding, capable of doing routing. And see what we are doing here. We are actually, whatever the blue links you are seeing, these are my layer 3 links. On these layer 3 links, I am running OSPF protocol, as simple as that. So if we have 10, 20, 30, 40 VLAN here, means 4 subnet. We are having 20 subnets here. We are having 30 subnets here and 40 subnets here. Then we need to exchange these routes, right? So that building number 1 can communicate to building number 2 or 3 or 4. What I'm doing for that, I am actually using OSPF protocol for that, right? And we can do that. We can make this as L3. We can make this is all as L3 and run the OSPF protocol. As simple as that, right? So if VLAN number 10 from here wants to communicate to VLAN number 30 here, the communication is going to be very, very simple. How? The traffic will be coming over this green link, will be reaching to this root switch where I have configured the SPIs. The traffic will be routed because we are learning the route over this blue link. It will be going like this, coming like this, and maybe here, and then reaching it here, right? And now you must be thinking, Mr. Vishnu, my boss, Mr. Prashant is saying we need to extend this VLAN 10 to building number 4 here, because there is one VP which I hired want to sit in this building, right? And who wants to have the same VLAN because other colleagues are sitting here. Although this is not a requirement, guys, right? But sometimes you get this requirement as a network engineer, and believe me, you need to stretch this VLAN. So there are different mechanisms in today's world. We can extend the VLAN over this L3 link, which is a new technology, which is going to be VXLAN, which we'll be talking about right later. Otherwise, we need to extend the VLAN over our normal trunk links. And for that, what I need to do is I need to connect, believe me, I need to connect this switch to this switch. And this red link, whatever I'm drawing, is my trunk link. If that is the case, now the communication can happen. No routing is required from the traffic of VLAN 10 will come here, can go here, over this trunk interface can come here, and then they can communicate, right? interesting. Today, believe me, I am not going to start HSRP. I think you understand the need of it. Just ponder about it. Just try to think about it, right? In next class, we will be talking about HSRP for at least half an hour. I'm not going to into the much detail, but the concept you already understand because HSRP is important in understanding a future concept which is known as Anycast gateway, and that is why I am coming into this. Okay. So in next class, we will be talking about HSRP. In the meantime, if you have any doubt, any question, please do ask. Otherwise, we can call it a day. Anybody? Any question? Okay, Mr. RR has question. Mr. RR, please ask your question.
Vishnu, are we doing lab for this type of scenarios or how it is?
No, if we do the lab, then basically, but believe me, lab is just nothing, right? If you have
Yeah,
the
yeah.
capacity of like this, then what is in the lab? You connect some devices here, and believe me, you need to do like this. I think I forgot to tell you. Now, the new switches which we have introduced here, right? And I forgot to tell you, and thank you so much for asking this question. So basically, these switches, whatever I'm introducing, is your core switch. So what you need to do, Mr. RR, right? Just create this network. It is very, very simple, right? Some access switches connect some of the host here, right? And by the way, this can be done only in the packet tracer if you do not want to use even eVNG. Maybe what I can do is maybe I can create this topology and record a video offline. It doesn't need to be
Yes,
online,
yes,
right? And then
yes.
then give it to you in the same course itself. This is the distribution, but basically I do not. I have done this so many times that I feel little bit bored. But if this is first time for you, Mr. Ara, please do that, right? Then the
Yeah, yeah,
core,
yeah.
these are your going to be L3 link. And believe me, it is going to be really, really interesting. Now I am saying that this link is going to be the single point of failure. If this fails, then nobody from here can reach to internet or any uh, when they need the layer 3 routing, nobody is going to reach. And that is why we are going to put HSRP here. So overall, you just need to create this diagram. We have access, distribution, and core, and that is it. Mr. Supreet has question. Mr. Supreet, please ask your question.
Hey Vishnu, thank you. My question is not related to this. I have a question related to one of the BGP scenarios that I was scratching my head since last 2 days.
Okay.
So can I ask this or can
Maybe
I
we
ask it
can
in
we
the
can
group? I
stop
was,
the recording here and then you can ask. Okay.
yeah,
So
sure, sure,
thank you
yeah.
so much, guys. We will be coming back with the switching topics next week. And next week is going to be the last week for this course, and we will be starting multicast next. Having said that, bye for now. See you.